So welcome to this webinar organized by the EUCloudEdgeIoT initiative. So this is part of a webinar series that Martel will explain later. Today we are here to talk on cognitive cloud infrastructure, so artificial intelligence to make it fast, lightweight, and performant. And for that, we will have the representatives of 5 projects that were funded under the topics of software technologies and cloud computing. So that's ICT 50 and ICT 40. So we will have the main outcomes presented today, because most of these projects are already finished, or they are going to be finished in the next months. Yeah, and I have to say that I was the coordinator of one of these projects, so PIACERE, that will be presented by Joao, who was the innovation manager of the project. So the idea is to start with the projects from the software call, and then go to the cloud computing call projects. But before we start, I would like to give the floor to Albert from Martel, who will give a brief overview on the webinars series that EUCloudEdgeIoT is organizing, and this is one of these webinars. So, Albert, the floor is yours.
Thank you, Juncal. Let me share my screen. I hope this now works. Please tell me if you see the right screen. Juncal?
Not yet.
So I have to push another button.
Yeah, now yes.
Okay, so thank you, Juncal, for the introduction. Very quickly, an introduction on the EUCloudEdgeIoT initiative, which is basically a collaboration of 2 CSAs, Open Continuum. I'm the coordinator of Open Continuum, together with Unlock. And we are organizing joint task forces to support the RIAs that are ongoing at the moment. There's another message here. But I would like to highlight the series of webinars that are organized under Joint Task Force 6. Katrina is in the call. She's leading some Joint Task Force 6. So we had some webinars already. There's a few more in line. So the first 6 that you see here with the dates. Today we are focusing on the software technology revolution and cloud computing innovations, organized by PIACERE, as Juncal was leading this. The CSAs behind the EUCEI, the Cloud Edge IoT initiative, as I mentioned, Open Continuum and Unlock. There's a few objectives that we try to reach within the next few months, as we're still focusing on supporting the RIAs and then hand over to the next CSA. But the basis is to open up an engagement with a reference or an open ecosystem and industry. From the supply side, that's Open Continuum, and Unlock is doing this for the demand side. So we're focusing on market scenarios, the interface between the supply and the demand side. And this is where we support also the relevant EU projects, portfolios management for the EC, and the research calendar for the next few years. Now, looking at the joint task forces, and all in the audience, if you're not aware of this, please visit our website and see if there's a contribution you can make or benefits you can take from the joint task forces. So that it's about strategic liaisons with EU research initiatives, but also with the industry, but also with IoTI, ECS, Gaia-X. So having a broad audience to make sure that you can understand and study how the impact of your project fits within business models, business engagement. But it's also about open source with Eclipse. We work on open source. It's about architecture. So Open Continuum will deliver a common taxonomy combined with a reference architecture that is needed to make sure that we all speak the same language when we talk about edge, when we talk about IoT, AI together. Today we will hear about that. Unlock, BlueSpec, and IDC, I said, working on the demand side. So it's the open calls, it's the use cases, but most important here, it's the value chain, how that we can work on this. And Open Continuum and Unlock together run Joint Task Force 6, as I mentioned. So this is about coordination of common events and webinars as we have here today. The activities diving into Joint Task Force 6 is about community building. And
Albert, sorry to interrupt you. Can I share the screen because you're not showing the updated slide for this section? So maybe I can show the screen.
Just downloaded it from this. Yes, take over then, please, because I took over from what.
Can you stop sharing?
Yes.
Thank you.
I think I can. Okay. Cool.
Who has the superpower can drop.
Yeah.
Can you see now?
Yep.
Yes.
Okay, continue, Albert. Sorry to interrupt you.
So on Joint Task Force 6, thank you for this. I just downloaded the slides that were uploaded to the portal that Juncal asked for. So we have the Joint Task Force on communication and community building. Current in the task force are 45 RIAs collaborating together. The new ones should be invited to join here as well, because it's the way we collaborate to make sure that we engage with the broadest audience. So we have the summit with EC, we have EUCEI webinars that we have today, and the value chain adapter workshops. And you see here the community is growing. Now 45 projects are listed, and we intend to extend and then hand over to the next CSA in a few months. I think this is my brief introduction, and any questions, please raise them in the chat. Katrina, I am here to answer the questions. Thank you for that, Juncal, and please take it from here.
Thank you very much, Albert, for your introduction. So as you have seen, the next webinar will be on the 3rd of April, and I don't remember the next one, but so it will be a quite busy period. So please engage into this webinar if you want to be aware of the outcomes and the results of this community of projects. So as said, today we will talk about 5 of these projects coming from the last software and cloud computing calls. And without further delay, I would like to give the floor to the representative of PIACERE project, Programming Trustworthiness Infrastructure as Code in a Secure Framework. So today, Joao Pita from XLab, which is the Innovation Exploitation Manager of the project, will be presenting the main outcomes of PIACERE. So, Joao, the floor is yours.
Thank you very much, and thank you also for the invitation for this wonderful event. The question of the 21st century. You see my screen, right? So.
Yes.
So what I'm going to present the logic and the outcomes on the project for the programming of trustworthy infrastructure as code in a secure framework. Very much addressing the security on DevOps and the paradigm of infrastructure as a code in modeling language as such. This project was engaging 88 partners from 4 European countries. It just finished in November, and it aimed to address this transition between the virtualization at design time, the cloud continuum, computing continuum, and a secure DevOps philosophy to be in place and in practice in order to provide tools that allow developers and DevOps teams to have to better care of infrastructure as code, and address the needs of a DevOps modeling language that we call it the DOML. And we wrote plenty about it. So there's much literature that was written and is being written on this context, enabling the automation of several deployment, configuration, and management tasks that otherwise would have to be performed manually by an operator. So always in the sense of automating the processes, and here, of course, artificial intelligence takes an important role, and we've seen that in the recent past, that there are several initiatives going towards the automation of this type of activities, which are difficult to automate through artificial intelligence, and so it is very important to have a clear methodology and understanding. Also, to which bring us to the context and motivation and general challenges that drove us into this on the scarcity of tools and tool sets and technologies that are to address this and that continue to propose the focus on a single set of automation steps, almost like Eclipse-based single window to all the problems we might have on addressing the DevSecOps. Also being cloud computing oriented is very important for us, and therefore a very strong link with the CloudEdgeIoT initiative, partial conversions coverage to DevOps processes, and last but definitely not least, the trustworthiness and the security of all the processes from the design time to the runtime, including self-learning and self-healing processes. And so, if we look into this classical figure of the DevOps with the security in the center, in the core, this is almost like a way of perceiving security and caring about security. We have developed several modules, several results, several outcomes that, although having their life, their relevance in separate, they very much complement each other into a unique solution that it's available over GitLab. And it lives on in somehow, in not somehow, but in certain ways in different projects. Some of those we have seen in the slides of our colleague Alberto that are engaged with EUCEI CEI initiative, being ICOS, for example, on the IoT to cloud continuum, but also Emerald, where Technol is furthering the whole DevOps designing, but also Silcomed, where we are very much involved on bringing this security coverage onto medical devices, and Sunrise, that is mostly addressing the critical infrastructure and in through a lot of artificial intelligence applications, but also with a great interest on the security of infrastructure and of those applications as well. So if we go and dive into a little bit on the results and benefits of those results, we always start by the DevSecOps modeling language, so this DOML that we named it, and that can be accessed over the Eclipse IDE that we make available, and provide us the codes that can be then addressing different types of infrastructures and different types of options of a unified deployment configuration, and particularly solving specific requirement specifications, allowing to then be transferred into well-known EAC infrastructure as code languages. The design time security, so still at the design time, has a tool that is also made available in separate, the EAC scan runner, where the tool goes through and identifies vulnerabilities and problems on the EAC code itself. It can recur to different checks, some of them being let's say open, some of them not. They also gave rise to some more commercial oriented solutions, because it is very important to understand clearly those vulnerabilities encountered in the code and in the dependencies so that the security is engaged and is ensured, decreasing, of course, response time and minimization of data losses as consequences. All of these being inline and accessed over the IDE. Then we have an execution manager that will execute the DOML with efficient provider specific infrastructure as code write-up and better deployment agility, workflow automation, allowing for this codes that DOML code where all the specifications were present to be translated into the deployment itself. And the optimization platform will still allow us to optimize the code itself, so that we take into consideration cost, performance, and availability of optimization, and also user requirements, the infrastructure that is considered to enable all these decisions that are difficult to be made by a human, to be assisted in this era of AI assisted solutions. The Canary Sandbox environment is then a way of testing or testing our experiments and ease the preparation of the deployment of the environment in the well-known frameworks like OpenStack or AWS that allows early identification of issues with the EAC itself, or customization of the testing environment, and prepare all that. And finally, at the runtime, we have a few, also much innovation there, including AI-based anomaly detection on logs, but also this relation with the matchmaking, rule matching security process to identify the securities on the logs, on the infrastructure logs, also application logs, but also then a system that will allow us to go back and identify some alerts and even some mitigation measures in a self-learning and self-healing context, with the deployed security agent being automatically deployed, this incidence response that I was mentioning being all automated in some way and learning based on what it's seeing. This is part of the great team that we had in the years that we worked together. and some of which are working in other venture, let's say, now in the future to come. So I'll be glad to take any questions maybe later on. I guess that's the plan, Juncal. So I'll pass the floor to the next participants.
Yeah, thank you very much. Yeah, thank you very much, Joao, for this nice presentation of the PIACERE outcomes. Yeah, the idea for the question and answer session would be to keep it to the end so that we can give as much as time as possible to the projects to present them. Anyhow, if you want to also put your questions in the chat, we can then go to them in the last session. Okay. So then, yeah, let's move to the next speaker and the next project, which is Cosmos, which will be presented by Sebastiano Panicella. So Sebastiano, the floor is yours. Thank you very much.
Thank you very much. Everyone, I'm Sebastiano from Zurich University Applied Science, and today I'm going to talk about Cosmos, Horizon project, H20 project on development automation for cyber-physical system. And this has been the work of 12 partners, 4 university and 8 use case and industrial partners. To go in the context of the project, cyber-physical systems are changing the way work and life is for everyone, especially in Europe. You can say that they are the foundation of the change of the society, and I think they represent the future. And cyber-physical systems, which are those systems that have embedded software that perceive the environment, make decisions through the environment, and is controlled by software, embedded software. Uses in different sectors, from healthcare, avionics, automotive, many of these contexts, and more used in everyday life. So they're very critical to change society. They will impact also the future of our economy. Downside, using those systems in real world, whether they are self-driving car, whether they are airplanes, or even small drones, I think Switzerland, they can harm humans. Because it's very difficult to test those systems. The level of observability, testability, predictability of those systems in real world is quite limited. And that's bring us to the attention to have more fast, reliable development of testing automation for those systems so that we can prevent that those things will happen in real world. That's where the project stems in, the main motivation. We need development automation for those systems, testing automation if you want. And DevOps is the technology we believed was the most important ones. The only problem that this technology is not meant to work for cyber-physical system. That's why we designed a project that will move on to DevOps for cyber-physical system. And we have built our project toward 3 pillars. The scientific pillar, which are really the work package, innovation items that touch different data, from automatically configuring the pipeline through testing automation to also runtime monitoring and self-adaptability of cyber-physical system. We'll touch base on those more in later. But the idea that once these components are developed, they are integrated in containerized technology, starting from Docker to, for example, Jenkins, plugins, and so forth, so that they can be easily integrated in our use case partner environment. The idea that these technology are used by those use case partners, so that in the loop, when we give them the tool and there is integration, we get feedback. It's easy to evaluate what we have developed through KPIs we designed before the project, but also evolved during the project. This technology have been evaluated through different use case partners. We have 8 partners. Some are acting as developer. We have very nice 5 use case scenario. We go from automotive, avionics, to medical system in the context of Siemens Healthineers, for example, but also utilities like water monitoring and railways with Comedia. It's quite a diverse set of scenarios. So we can really plug in different kind of tools and see the depth of our automation, the usefulness in different stages of the DevOps pipeline. And our technology have been developed through different innovation area. In the first area, really chronologically, the way they are subsequently connected to each other is DevOps pipeline for CPS. We know that DevOps pipeline are not meant to work for superficial system. First step is to identify automation to adapt to this CPS context. So the first part was almost even empirical, happened before the project, at the beginning of the project, find anti-patterns in the adoption of the DevOps for CPS. But then we went ahead with the way to self-adapt the configuration and maintenance of the pipeline with the focus of optimizing its usage. To give an idea, for example, of the start, and then where we move on from the next innovation area. When we started the project, we knew and we already expanded our knowledge and identified challenges in using DevOps for CPS. There are papers on it. That's one example, for example. And the idea that there are different areas that limit this their adoption. One example is that there is a lot of flagginess, for example, in testing CPS, and this is mainly due to the specific characteristic of superficial system. For example, the common unavailability of hardware, and for example, timing issue. There can be related to different problems, for example, network issues, and so forth. The idea there are many more challenges. I don't want to go there motivating, but the idea that there was the stem to say, okay, those are the challenges that we want to face. Let's tackle them with automation, not only from setting up the pipeline, but also go beyond that. And the second innovation area really focus on verification and validation, security aspect of the DevOps pipeline. And if you want more precisely, testing automation, enable testing automation, superficial system, runtime verification by checking system level properties of superficial system, and even security aspect. As you know, superficial system compared to normal system, even AI-based system are the same, are very easy to attack, and they expose higher risk, not only from a system level perspective, but also for the environment, human being that they are around the systems. Here, to give a bit of an example, what we did, we built a testing automation environment, which is very generic, co-developed with this different partner. And the idea that this environment communicate with the physical engine and the simulation engine, this allowed us to do different things. For example, one thing that we could do is leverage and implement on top of this initial environment, test execution automator, a physical testing optimizer, which is machine learning to determine the seeds, if you want, the states that can identify corner cases where the system will not work as expected. So cases where in simulation, we know the system will not work in a safe way and avoid that this will happen in the physical world. That's quite important aspect. As you can imagine, much more innovation will be done in runtime monitoring and testing automation. I want to give you a bit of an example what we have developed. The subsequent area, once you know how to do runtime monitoring and testing automation, is how to keep the quality of superficial system on a high level. So there is an area that is about having high quality of CPS through software evolution. And one core area is to automated refactoring of superficial system, not only related to software. Test generation, rapid test generation. The idea is to decompose system level test case in lower level test case that can rapidly be executed. And also the idea that humans have an important core element for evolving those systems. So we also managed to develop technology to enable humans to give feedback so that the system can be evolved through that innovation. To give an idea, just rapid iteration, one thing that's very important is to be able to test quickly. And one element, for example, was necessary in the context of automotive was to get the ability to get real maps from real world, plug in the simulation environment, test what happened if we have the car behave in a certain moment, in a certain environment, and discover corner cases. It was quite, for example, technology, but also research environment. We use genetic algorithms, if you want AI, to find corner cases by manipulating variants of the real world maps. Then finally, we have a fourth innovation area, which is monitoring and self-healing and self-adaptability of CPS. The main core aspect is that we want to focus on testing and, if you want, monitoring self-adaptability of the system when it's in the field. The idea when we test this system, we go from the field to the testing environment and vice versa. We want to make sure that when we move from testing environment to the real world, the system still works as expected. One thing that we try to monitor is or assess is strategy to change or monitor change that will affect the behavior of the system, and see how a change, whether it's software or hardware related, will be basically observed or will impact the behavioral system in the real world. And then we develop different technology to make sure that we can, with high fidelity, move from real world to field testing, know that what will happen in the real world as constant with the simulated environment. And the idea that monitoring is a quite important element to enable self-adaptability. If you can monitor how the system behaves, you can actually make engine that can allow the system to self-adapt, whether you try to focus on test environment or at runtime. To give an idea, okay, what is we are talking about, I give an example. Assume you are a drone developers, or users, you have a managed area vehicle that is able to navigate the environment with high autonomy, but you have some corner cases, cases where the drone doesn't work as expected. One scenario we have developed is a technology that is able to replicate logs of real flight, what happened in the black box of the intelligence of the drone, and replicate that behavior, that commands that allow the drone to have this unstable behavior, unsafe scenario in simulation. The idea that we can not only identify the root causes of it, but we can also determine variants of commands that could have led even to a crash, which was not observed in the real world, preventing what will happen through simulation. That's also an example how to move back from real world to simulation to real world. That's quite on a bigger problem of robotic and software engineering. Concluding, we achieved a lot of impact. And, first in the beginning, we had to really move on from testing automation. It was a bigger challenge to move on in this research. But then we were able to focus on different areas, which goes from vulnerability and security, deployment, automation, and so forth. There were the two, from the moment of the project we observed. And we were able to impact already DevOps ecosystem, if you want, open source community, but also industrial community through our use case. We have very precise standardization action through technology we have developed with an impact that, of course, has been divided from publication to writing probably the first book on DevOps for CPS, which will be delivered by the end of the year, beginning of next year. To give an example of technology standardization, we have developed IRList, the first technology that allows to test and monitor unmanned aerial vehicles, if you want drones, whether you're doing simulation in physical world, with different engine that can, makes us confident that the drones will work as expected in the real world. This has been the core element, artifact of tool competition from the community, and you can download the software and run it locally, as you can see from the link that is shared. But also we have built for probably the first technology that allows to test through CRAN-Bus protocol. I don't go in details, but you can test the system unit of a car through simulations, simulating signals. And the idea that is also technology to test self-driving cars has been developed and made available. So you can play with it and with an extensive documentation in both cases. I said that I want to, thank you for your attention. Hopefully that give a bit of a glimpse what we have done, what we're still working on, and, the future to come. Thank you very much for the attention.
Thank you very much, Sebastiano. It's very nice to see, how software engineering practices and DevOps practices are customized for different purposes, like infrastructure as code in PIACERE and cyber physical systems in Cosmos. So nice. So let's continue now with the cloud computing call project. So I will give the floor now to Tariq Ben-Merar, which will be presented Charity project. So Tariq, the floor
Hello,
is
can you hear me well?
Yep, perfectly.
Okay, so I start sharing and then I start my presentation. Okay, everything is good?
Yeah.
Okay, so today we will present the charity project, and I will be focusing particularly on its orchestration system as let's say a big innovation and contribution to the IoT Edge Cloud. So these are the charity objectives. So the focus is to develop the orchestration system for XR applications. So these include highly interactive applications and also related to real-time media solutions. These are the partners and in the consortium. So we have a couple of XR companies like Orbital Night for gaming, Hologram 3D, and Seer for everything related to hologram. Orama VR for interactive medical applications, Collins Aerospace in the aerospace industry, Ciango for interactive tourism, yes, and also a couple of research centers and companies that develop let's say, the technological aspects as well as to develop the infrastructure. So these are the 6 use cases for the projects: the holographic concerts, virtual reality medical training, collaborative gaming, etc. So these are the 6 use cases. So the XR develop begins by developing the code and the image, to build the image from it, upload it to the XR repository. It needs to express the topology through a blueprint template editor, so and deploy the model using the deployed repository. And then you have the charity orchestration that places the application components and the monitoring to monitor what is happening to adapt and reallocate. So the main, let's say, aspects that encompasses or a lot of partners' work is the multi-level orchestration system that we have developed. And we have 2 publications that I invite everyone to take a look. So the main contribution is to have a multi-level orchestration systems where the AI part is, let's say, have a dedicated components. And we have, let's say, scalable low-level orchestration systems to manage how to create and ensure that the target state is achieved. So we have let's say we start the orchestration system with the IMF, which is a visual language for the application developer. And it's the objective is to express the intents. So for example, this topology descriptions relates to the Ciango components in the charity project. From this, let's say, UI, a Tosca YAML is generated with all the components and properties and constraints. Of course, we have extended Tosca to include everything related to multi-domain edge cloud. Also enriching Tosca with new types, like, for example, to support GPU, having components with placement constraints, connection points, and ports, etc. Now, the high-level orchestration, which is the AI part and handles the decision-making aspect, receive the intention blueprints and also monitors what is happening in the infrastructure, and then generate an orchestration blueprint. So the orchestration is really focused on a document-only pilots. There is no actions that is generated, only states that is generated. And of course, the AI algorithms can be integrated at this stage. For the low-level parts, which receives the orchestration blueprint, manages the low-level orchestration and enforcing the decision-making. And in this part, we have, let's say, harnessed the operator paradigm that is used by Kubernetes, but we have extended for the needs of the charity project. Of course, it ensures that what the high-level orchestrator decides, it ensures that the right infrastructure status is achieved. So it monitors the low-level parts of it and ensure that target status. And the low-level orchestration received, as we have explained, the orchestration blueprint, which is also a document. And we have the operator that creates all the necessary components, clusters, links, and applications to create the application for the user, the developer, the XR developer. And we should emphasize that in task force 3, work group 5, there have been agreements to on this fractional view of orchestration building blocks, and follow this proposed paradigm with some let's say changes, minor changes, and also other projects have followed this paradigm, like I mentioned, Iris, which proved to be scalable, and also you can have different partners to work on different parts independently and in scalable way. So these are, let's say, the main contributions we wanted to contribute and to show as an innovation aspect. And thank you for your attention.
Thank you very much, Tariq, for your nice presentation. So let's move now to the next project, which is AI Sprint. So Danilo will be presenting it. Danilo, floor is yours.
Okay, sorry, issues with the screen sharing. So you see my screen, right?
Yeah.
Okay, great. So thanks everyone and for attending also, and welcome also from my side. I will introduce which are the results, the development that we achieved with the AI Sprint project that just ended at the end of December last year and had its review last February. So AI Sprint has two main ingredients. One is edge computing, and the other one is AI. Edge market in Europe is in a good health, in my opinion. These are recent data by IDC. Actually, the EU companies are using Edge, and this is gonna double in about the next 2 years. And if we look at the market size, this will reach about 33 billion. And the cloud take for this about the 23% as the backend of the computing continuum, while artificial intelligence is about 12%. If we look at the driver that helping the companies to motivate the companies to move to the edge, we have performance, cost, and cybersecurity that have been the main focus of the AI Sprint project. So what we have developed in AI Sprint, we have developed a full DevOps approach for the development of AI application at the edge. We provide performance guarantees for our application. In particular, we consider the traditional throughput and the latency of the application, but also energy consumption. So, for example, we can, while we train in an AI application, we can move from one data center to another if energy profile of the second data center is better. And we also have some specific solution for the security of the applications. We developed both a design time environment and a runtime framework. All the design time tools are packaged into a Docker container that can be easily downloaded. Here we have several tools. In particular, we have a Sprint Design and PyComps that just through component annotation allow us to introduce performance constraints to our application and also to parallelize the application. We have Toskerizer or Oscar P that on one side automate the packaging and the deployment of a complex AI pipeline to the edge, and while Oscar P is able to automatically profile the application and to identify some machine learning models that allow us to predict the performance of application under unseen configuration. These models are then exploited by Space4AD that, given the different alternatives on which the target AI pipeline can be deployed, identify the solution of minimum cost that fulfill some performance constraints. The application then can be secured to SCOAN, which has been developed by our partner, the Technical University of Dresden, and in a way that the application can run on trusted execution environment, so can exploit, for example, IntelliSGX, but we have also developed some secure boot and measure boot solution in case a trusted execution environment are not available. The application then can be deployed automatically by the infrastructure manager, which has been developed by the University Polytechnic of Valencia. And so infrastructure manager is a cloud orchestrator, which is a TOSCA compliant, that allow us to automatically deploy on the popular cloud provider, but also we have a specific focus on European cloud provider like CloudEdgeIoT, Telecom, and also Telecom Cloud, and also EGI, on the EGI infrastructure. The infrastructure manager allows us also to automatically deploy the application on any cloud which is compliant with OpenStack. Together with the application, we deploy also the iSpring runtime in a totally transparent way for the end user. We have developed a monitoring system that gather metrics at the tool stack. So we gather infrastructural metrics, but also the application level metrics, and so the developer can also define novel and application specific metrics. Then we have the automatic runtime management of the application, and we can rely on Krake, developed by CloudEdgeIoT, which is a manager for energy management of the application, and Space4IR, which on the other side is in charge of fulfilling the performance constraint of the application. Given our then the application can run on Oscar and SCAR, developed by Valencia, which provide a functional service environment for running the AI pipeline. And this is very important because in this way, request you use resources only when they are active, and that's really relevant because we save cost on the cloud backend, and we save the resources on the edge. And usually, frequently, the edge is the bottleneck, so that's really relevant. Then, given our focus on AI, we developed some verticals for that. So we developed a solution for validated learning, privacy assessment, and also for automated network architecture search, in a way that just given a label data set, we can identify automatically the best deep neural network that trade-offs the accuracy of the application with its performance. And finally, we have also a scheduler for the training of the application that can provide guarantees to the training application. So one developer can say, I would like to have the result of my training by tomorrow at 10, for example, and then the scheduler identify the cloud solution of minimum cost for in case of public cloud deployment, but we also minimize the energy for on-premises deployments. We have fully documented our tools that are available. 90% of the tools are open source with a non-viral license, and are available from the SpringOS site. The solution have been validated on 3 use cases. The Farming4.0 have developed a runtime sprayer that on 1 yard can optimize the adoption, the usage of phytosanitary products. We have developed a maintenance and inspection application where a drone can take a picture of the windmill and filter out, performing some local computation, filter out the images that are not including any defect. In this way, we can save bandwidth and transmission to the backend cloud. And finally, we have developed also a personalized care solution where our partner have developed an application for stroke risk assessment that mixes some information on the patients with information coming from ECG that are taken in real time with wearables, actually. And they are also gonna start a startup on this application. So that's all. If you have, I'm open for questions.
Thank you, Danilo. Thank you very much. Let's go now for the last project, and then we will have some minutes for the questions if someone has question. Okay. So the next will be Panagiotis presenting Serrano. So Panagiotis, the floor is yours. Thank you.
Can you see my screen?
Yeah.
Okay. Hi, I'm Panagiotis Kokinos from ICCS. This is an overview of the Serrano project. It's about transparent application deployment in a secure, accelerated, cognitive cloud continuum. The project finished in December. It had 11 partners from various organizations and industries in Europe. The Serrano platform that we built in this project targeted infrastructure consisting of edge, cloud, and HPC resources, and we built a continuum. We actually, in our evaluations and use cases, we had certain infrastructure, so we have edge resources. We have edge and cloud resources that consist of generic servers, of GPUs, DPUs, data processing units, and FPGAs. We have the multi-cloud resources, storage resources, and we also have an HPC infrastructure available. The Serrano platform that we built adopts a lifecycle methodology that facilitating application deployment and cognitive orchestration in this continuum. It has 4 steps. The first 2 steps is about the transparent application deployment and the translation from generic intents to specific objectives. And the final 2 steps it's a continuous and autonomous allocation and adaptation of resources and of applications. So about the transparent application deployment, we have an app that we implemented that includes an AI-based mechanism to describe application characteristics and specify infrastructure agnostic intents, mechanisms that translate this from Tosca specifications to the Serrano specific applications and resource models and to Kubernetes descriptors. And we have an AI-enhanced service orchestration service that use these models and creates deployment objectives utilizing AI and ML algorithms. Regarding the continuously and autonomously adaptation of the continuum, our platform has the resource orchestrator, the resource optimization toolkit, and the telemetry framework that enable the orchestration of the continuum using AI-based mechanisms. We have a 2-stage approach where we have the Serrano central orchestrator and local orchestration mechanisms that cooperate with the Kubernetes clusters. We also have the HPC gateway service that interacts with HPC systems. And also we have the service assurance and remediation service and the event detection engine that detects events regarding the infrastructure or the application and optimizes the infrastructure. Also, the Serrano platforms introduce a number of innovations in several areas. So we have a Serrano storage service that enables secure storage in the edge and in the cloud using erasure coding. We use NVIDIA's data processing units for accelerated data processing so as to reduce the CPU overhead through TLS offloading. We have a lightweight hypervisor that runs using kernels as functions so as to isolate instances and to reduce the attack surfaces of the applications running. We developed both hardware and software-based kernels based on FPGA, GPU, or HPC systems that are utilized trans precision and approximate computing techniques. We have the VXL framework extended, facilitating access to hardware accelerators by applications that run as containers and functions. And we also incorporated in our platform the OpenFaaS serverless framework. And in the end, we had 3 use cases through which we illustrated Serrano platform operation over this edge cloud HPC infrastructure. We have the secure storage use case where we're able to, with a secure and high performance manner, storage files. As I said, we use hardware accelerated TLS offloading, reducing the total number of CPU cycles. we are able to showcase that we can serve a large number of client requests. In the second use case, the fintech use case, we have the dynamic portfolio optimization application. This application utilizes the Serrano platform so as to access FPGA and GPU-based and HPC-based resources. And we saw that in this way, we are able to increase the number of generated portfolios, to have higher expected return, and to maintain a low possible risk. Also, we are showcasing that with the use of the edge resources, it's also possible to reduce the cloud costs. And the final and third use case, it was the anomaly detection in manufacturing settings, where the goal is to detect machine anomalies, machine problems, without stopping the machines. And we showcase that we are able to process in a timely manner streaming data coming from the machines, leveraging the Serrano platform and the Serrano acceleration mechanisms. And in this way, we're able to perform continuous health assessment for the machines, and we're able to predict imminent failures regarding the machines and giving enough time to handle these imminent failures and to avoid severe machine failures. So that's all from the Serrano. And thank you, and I'm happy to answer any question.
Thank you very much, Panagiotis, for your presentation. So even if we are running out of time, I would like to open the floor to questions, if any. I cannot see any question in the chat, but maybe some of the attendees want to ask some questions. So let's open the floor. While people is thinking if they want to ask something, I have to say that this webinar will be available in the EUCloudEdgeIoT webpage, and also the report that we will be creating after the webinar. Yeah, so I can see a hand raised by Maria Zacali from the European Commission. So Maria.
Okay, hello, can you hear me now?
Yeah.
Okay, thank you very much for this webinar. I just have some questions concerning now from the experience that all the projects have gathered through their execution of their work. What are the challenges now? What do they believe that we should really include in our next work programs? What are the major issues, the major areas of further research? And I mean, from my point of view, I would very much like to see the projects that did the work on the cognitive cloud. What is your feedback, to the projects that are running now, the new ones, and also what is your feedback for the next work program? Okay, what are the challenges in this area in cognitive cloud and cognitive computing continuum? Thank you.
Thank you. So who wants to take this one?
Yeah, I can say my opinion if you like. I'm Panagiotis from ICCS. From our experience, one thing that we've seen, because we participate as coordinator in another project that started last month, and challenge is always about the industries that come as use case partners. In the Serrano project, we had a lot of talks about, we have partners with different experience regarding edge and cloud. So some partners were experienced, so it was easy to talk with them and help us, building our platform and finding out the right requirements. Some partners were a little bit less experienced about the technologies that we handle, so we needed to guide them through what we need from them and how we can enhance their products or their services. So this is a challenge, and this is what I think it's important. Try to go to industries in various areas and in one hand understand what they need, and on the other hand explain to them what they can gain from our technologies that we develop in the EU. So the goal is to try to put the technology that we developed and the software that we develop, all the projects, to put them in a good use in these industry communities. That's all. Thank you.
Thank you, Panagiotis. And Tariq, want to say something too?
Yes, just a small comment. So for now, the challenges is, let's say, two main things. The first one is how to integrate the AI really into the inner working of the orchestration. So we have started some experiments, but on the long run, it should be really something that will be integrated into these systems and to have more elaborate AI algorithms. The second thing is really how to allow, let's say, any developer to scale its application across domains, which for now, I think it's reserved to big companies, which, let's say, for example, such as Zoom, which has, let's say, different edge servers to create these video conferences, etc. But having this power to any developer, it's really a challenge and something that I think needs to be achieved to have the scalability, fully automated, fully deployable for the developer. That's what I can add. Thanks.
Thank you. So I think the next one was Danilo.
Thank you, Juncal. I think I believe that there are two main concerns for edge computing and for AI. One side, I believe that there are more need for and effort for standardization because the edge is really heterogeneous. And while, for example, there are some standards for cloud nowadays that have been reached by industry too, there is much more work to be done on the edge side. And on the other side, this is also in the news. I believe that we need to make our solution, our system, more energy efficient because really AI is interesting, but energy consumption both for the training and especially for edge, because while the training can happen in efficient data centers, the inference happen at the edge. The edge is less energy efficient, and also the inference happening at the edge is growing with respect to the training. So I think there is it's important to pay attention to the energy side of our applications.
Thank you, Danilo. So now, Sebastiano, the floor is yours.
Now to give a bit of what we learned from the project, a different meta question. To make it work in these larger scale projects, really to have technology that are sort of agile. You can easily integrate in industrial partner, for early assessment, and also to have a community involvement. So what we did, for example, make it really work and scale, even as a community. We built a prototype, we put it out as sort of publication, but really the artifact was there, and there were competition. We invited people that were expert everywhere in the world to compete, and to make those tools better and better. We are doing year after year beyond the context of the project. The one winning argument, because you also get the community contribute, the tools are better, and when it goes back to the industry, that's essential. One thing's to come. We didn't really thought about that. It was not really expected the rise of generative model. Most of the CPS system, and now we are using a reduced generative model. If you want drones, they're using that for deciding where to go. And now they're using more and more system will use it. And for example, there's a lot of, we were talking about sustainability, not scalability. How much does it cost to run AI? But also when we reduce, manage to make them that sustainable, there's still security and safety. It's really key an aspect that has to be solved. For example, with the Swiss government, we identified items that has to be addressed when using large language model, writing a book as a reference, will be one of the outcome of the Cosmos project, but there will be others. And more generally speaking, it's really the interdisciplinary domain that has to be covered. I don't think when we go more from agile, moving different domains, really leading and stay just in the IT domain, we need to sort of people from robotics, from AI joining, and there are challenges that really in this intersection, these different areas. So I expect one of the requirements on new future projects really have to be stakeholders that are really different, completely diverse set of expertise to collaborate together. For example, our project was a strength that we were all from software engineering. But the idea, I think, is make it a step ahead is really to go beyond and in the boundaries of the challenges that are between, AI and software engineering to give an idea. I could tell more, we talk for hours, but that's the 3-4 main ingredients that I think we need to be considered from the past and the future that's to come. Thank you very much.
Thank you, Sebastiano. And now, Joao, let's see your point.
Thank
here.
you. Thank you. Yes, to follow the colleagues. In fact, the agile methodology is very important to be implemented across different industry sectors. We need to think about the difficulties that it is to be implemented in small and medium companies in Europe size. And in the scale of Europe, remember that a lot of industry, a lot of the companies are actually facing those challenges. And I hear artificial intelligence can really help with the AI agents, particularly acting not only at the DevOps infrastructure, but also on the context of having the security being overseen and things being done in the proper way, so that there's less needs of experts engaged on those and to actually make the outcomes and the results that the companies are having a bit more volatile. And finally, of course, standards here are very significant. We are with the EUCEI Act. We are going to see a lot of different, let's say, interpretations of different standardization approaches across the standard bodies in Europe and internationally. And those companies that are producing artificial intelligence or utilizing artificial intelligence to make their work agile will need to have that into consideration. And this is an effort that needs to be followed also in the context of this of the CAE in the forthcoming projects and initiatives.
Okay, so thank you very much. It's glad to see that you already have some ideas for the next projects. So unless there is more questions, I think we can close for today. I would like to thank you very much to the panelists and also to the EUCloudEdgeIoT initiative for the organization of this webinar series and this concrete one on software projects and cloud computing projects. Please be aware that the recording of this webinar and the post-webinar report that we'll be creating will be available in the web page. Okay, so thank you very much.